Thanks very much, Raj. I was delighted to see you pointing out the confidence issue, despite the emphasis that big names in machine learning like Michael Jordan at Berkeley have placed on the need for confidence intervals in machine learning algorithms. It's amazing to see that we see this so infrequently in the literature, particularly in health applications. I wonder to what extent this runs counter to how the FDA has traditionally approved technology in health, but that's something we can get into a discussion at the end when we have time for the panel, because I want to make sure we have time, the full time for our next panelist, and that leads us very nicely into this. Our final speaker in the panel today, wrapping up this bench-to-bedside pipeline, is Suchi Saria, who is the John C. Malone Associate Professor of Computer Science at the Johns Hopkins Whiting School of Engineering and of Statistics and Health Policy at the Bloomberg School of Public Health. Dr. Saria's research focuses on the application of machine learning to healthcare data, and she has been a recipient of many awards from the IEEE, Sloan Foundation, DARPA, and many others. So please do look at her bio to see the full scope of that. One reason we've asked Suchi to speak today is that she has also co-founded Bayesian Health, a startup out of Hopkins aiming to commercialize her research on sepsis prediction. I'm delighted she's able to join us today to discuss some of the key issues she's encountered in the translation of these algorithms from retrospective data to prospective use and commercialization. So over to you, Suchi. Thank you again.
Thanks, Gary. Very nice. Very excited to be here. It's always difficult to go as the last speaker in what is a very, very massive topic area. And we got to hear sort of a sneak peek into data quality issues, machine learning, the development of machine learning itself, and considerations in developing machine learning algorithms. And then also, you know, as we start to think implementation, that itself is not simple either. So before I dive in, I would like to thank the funders, in particular Gordon Betty Moore Foundation, where they've started funding me back in 2013 and were really instrumental in funding some of the very most creative work that's come out of our lab in sort of thinking through how machine learning can be used for doing early recognition of sepsis. So I want to, just as by way of background, talk a little bit about both my experience in the field and then also talk a little bit about as a field as a whole, where are we in terms of development? So first, my experience in the field, I've been working for about 7 years kind of on this particular narrow topic of can we use data, diverse data like structured, unstructured, labs, vitals, notes, clinical history, treatment, medication, and so on and so forth. Can we use that kind of data to identify sepsis early and make it possible to alter patient trajectory? By this, we mean by timely treatment and early treatment, is it possible to then, there's widely believed data that like if only we could recognize early and we could give timely treatment, then it would alter the trajectory. And the question is, can we use machine learning to really make it possible to identify it early? And the reality is, even if you identify it, if nobody is actually going to do anything about it, then, that doesn't really get you there either. So what does it mean to really do this? And wrote one of the early papers back in 2015, where we were looking at primarily ICU data. Since then, have expanded it from ICU to ED, data from the floor, one of the big things here is how, and working in this area, because you need to know so many things. It's really like a massive team sport. So, collaborated with an engineer, like a team of about 35 people at one point, which comprised people from human factors, quality improvement, and engineering to build infrastructure, because the deployment of these algorithms itself within workflow is a non-trivial thing, especially if you're not simply doing rule-based BPAs. We have to think about how do we pull data out of Epic in real time, or your any EMR in an EMR agnostic way. How do you push it back into the system in real time so that it's possible for providers to be able to use it without barriers? How do we do this, like Raj mentioned, in a way that is actually user-centered? And so we partnered with experts to do a lot of those kinds of studies. And then in 2018, deployed some of it in our first hospital, where it was across the board ED, floor, ICU. And amazingly, when we first deployed it, like even though the performance was great, the first 6 months or so, only like a handful of expert users used it. And the interesting thing was this, a whole science out of thinking about how do you build, communicate, message in a way that is improves adoption and engagement and robustness. And so we sort of made a lot of progress there as a team. We're able to be successful in some of our sites now. We have upwards of 85 to 90% adoption. That means every single time a patient is actually marked, a bedside care team member looks at it and does something about it. And effectively, as we've deployed, people are using it. We've done prospective study, measuring outcomes. Some of that data is going to come out. And, closely interacted with quality improvement, just like Shamim was mentioning. It's so crucial. What we found was, in order to really succeed, we needed to make it part of the culture. So it's not like an academic study where, you take data and you're sort of doing some machine learning mumbo jumbo to come up with some cool tool. But really at some point, physicians are like, our care team members are really busy. So the question is, why should they care? What should they do? How does this tie into a care transformation effort at the institutional level? And so working with, both our clinical task force, but also with QI to understand how to embed it within the culture of the institution, which is thinking about, communicating goals. What are we trying to accomplish? How do the tools support them in accomplishing it? What are the barriers or roadblocks in adoption? And figuring out, how can they learn over time as they're starting to implement and adopt the tool to understand where the gaps are. And now, most recently, have been partnering with systems beyond Hopkins to be able to deploy this in other areas. So obviously, this is a very big area, and there's lots and lots of things to cover. So I thought I would just kind of tie the panel together and talk about 3 key learnings. So first key learning is, historically when we've thought about scoring and scoring tools, we think of it as like framing hammer score, right? You build, you've gotten a panel of clinical experts together, you sit together and you come up with a risk scoring tool, and now the scoring tool gets used everywhere. In machine learning, in the last 7 years alone, or 6 years alone, since we've started to see the emergence of machine learning for real-time assessment of risk and risk scoring to drive provider action, there's been an enormous number of advancements in the field in terms of, how do we make the tools more precise? And a lot of it is all aimed at trying to make the quality of the tools better. And you might imagine, this is an ever-improving science. It's improving really, really fast. And so all the way from and Gary, among others, have done work in this space as well. But effectively, how do we take advantage of the unstructured and structured data? How do we tackle sparsity? How do we bring uncertainty to take the predictions where which are unlikely to be trustworthy and squash them? How do we communicate in a way that we can improve the ability of the user, in this case, the caregiver, whether it's the physician or the nurse, to be able to diagnose the model output so that they can understand which one to trust and which not to trust. And so in a nutshell, the point being, even since 2015, as we've published, there have been so many good ideas to continuously improve the sensitivity, specificity, and the early recognition quality of these tools. And they're increasing ever more so. One key area I want to draw attention to in the last couple of years is people have gone from deploying tools from one hospital site to another hospital site to a third hospital site. Natural question has been, how do we take advantage of, how do we build techniques that are robust? In other words, models that themselves give learning approaches that give you models that are transportable. Like they're naturally less sensitive to provider practice variations. And that's really important, improving reliability of these models. So I think first takeaway is whatever tool we think we have today, tomorrow there's going to be something that's better because this field is improving quality so fast, and there's so many opportunities for improving, including how do we make deployment on the note of precision and sensitivity specificity, like Chris talked about. How do we take this kind of unstructured data to improve the quality of the labels themselves? Because if you can improve the quality of the labels, the downstream quality of the prediction models you're developing itself will be better. So one key learning there is, I think we're in this RO1 mode of like one tool, we freeze the tool, we're going to study it for 6-7 years. But for me, like for our team, what we've learned is basically the science is evolving really fast, and you kind of have to think of it as there are all sorts of ways to improve a tool, a learning tool. But at the end of the day, the three metrics that matter are sensitive, like can you identify patients? Can you identify them reliably? Can you identify them early? Can you enable the caregiver in trying to act? And all of the innovations that can enable you to do that in a robust way. So that's our first one. The second is, like Raj mentioned, right now machine learning is very divorced from workflow. And when we think of workflow, we very much just think of it as interpretability and making it interpretable. But a key piece here is how do you tie it into workflow so that every single time you're calling for their attention, they feel it was a value add. So like how do you create opportunities for creating value at every point of the way? So for example, instead of having to rummage through the EMR, you're providing all the relevant points quickly. So that saves you time in the evaluation. Being able to figure out if you're attempting to, give the intervention of treatment, figuring out what treatments have already been given and what's pending. And we found this to be actually quite important in providers willing to consider adopting. Another key part of adoption was them being able to trust it. And trust came, a lot of it, from being able to diagnose the actual models they were seeing, and then also diagnose practice. In other words, once they started using it, being able to see how their own practice pattern was changing. And in particular, were there cases that they were previously missing that this system could have let them identify? Or are there cases where, we're overprescribing antibiotics, for example, and how can we reduce that? And then the third final learning, actually, I think this one is the sort of biggest open thread, is I think it's sort of a balancing act, which is I think we need to treat algorithms more like prescription drugs, in the sense that we need to move away from, in QI, where we deploy something and our ability to measure and compare efficacy is very, I think, weak. In other words, being able to understand, is it working? Is it really working? When is it working? When is it not working? Is so important. And one thing I found in this scenario, as we've deployed and sort of over time enabled QI, is that a large part of implementing tools for early warning and timely treatment, the question is, you can have the best tool in the world, but if it doesn't get behavior change, it doesn't get adoption in the right way, you're not going to get an output. So an RCT, a simple RCT, is very, very hard to do because you can't do double blinding. Like if you're going to change workflow, which you'll have to do, the people, your providers, are going to see the workflow changes, which means suddenly you're in this world where you can't run very simple randomized, RCTs. You're going to have to think about how do you do more clever designs that take into account the fact that there are bigger workflow-related challenges in sepsis. And then furthermore, how do you adjust for adoption as we measure efficacy? Because you could implement and deploy it in one system and it works really, really well, and you move to a different system and your results may be totally different. And part of the difference here is coming from, practice variation, adoption, engagement, etc., which is important to tease out. So this is my last and final slide, which is, I think as a field, there's been an enormous amount of progress on the availability of EMR and electronic infrastructure to be able to feed these kinds of real-time insights to the care team now. So you can nudge them at the right time to take the right kind of actions. The improvement in the quality of the machine learning algorithms and informatics algorithms to be able to derive very precise patient-specific insights, and this will continually improve. So the question is, how can we marry like, to me, the world of QI is still sitting at the level of billing codes, which is being able to, kind of, we can hardly even measure where our problems are. Like, if you ask them, like, what's our sepsis mortality today? Standard practices take out all the patients who were had a billing code for sepsis and then measure mortality. But in reality, we know that's a terrible practice. Billing codes are not very representative. So machine learning and the use of machine learning with real-time data and, coupled with providers auditing these inferences in real time provides a way for us to come up with a much more foolproof system for recognition. And the question is, how can we bring QI, clinical experts, and machine learning experts to work together in order to kind of do what I think is next generation clinical improvement, where there's much more of a notion of, learning, using spending less time doing data abstraction, which is where most of QI energy goes now, and spending more time doing change management and behavior change management and letting technology handle more of the information extraction, accurate identification, and timely interventions. With that, I'll pause. And then, Gary, if you have any particular aspects of commercialization that you want me to comment on, I'm happy to in the panel.